Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 9 to 6 that says flip string to monotone increasing. So here we are given one binary string containing zeros and ones, and a binary string is monotone increasing if it consists of some zeros followed by some ones. That means on the right hand side you might be having only ones, and on the left hand side you just need to have only zeros. So similar to this, you can't have intermediary zeros like 1 and 0 anywhere in the string. Then that's a monotone increasing string. Further, for any string, you can flip some of the characters from 0 to 1 or from 1 to 0 to make this string monotone. And we need to return the minimum number of flips to make as a monotone increasing string. Okay, so taking a look at this first example, here we have 0 on the right hand side. So if we flip this 0 to 1, then we will get this string, and this string is a monotone increasing string, correct? So instead of this, you can also flip two ones to 0. So it will be complete 0 string that is also monotone increasing, but that will take 2 flips. So that's not a better approach, as we need to return the minimum number of flips. Got it? So now here in this question, what you can do is either you can flip all the 3 ones, okay, or you can flip all the zeros, this and this 0, right? This 0 and this 0. So let me show you. So here this is the given example. Okay, so one possible answer here is either what you can do, you can make 0 1 1 1 1 1. So here in this situation you made this 0 to 1 and this 0 to 1, so number of flips you did is 2. Or one possible answer is what you make this 1 to 0 0 0 1 1 and this 0 to 1. Okay, so this will also take 2 flips, as you have flipped this 0 to 1 and this 1 to 0. So these are two possible ways to make this as a monotone increasing with minimum number of flips. Got it? Now taking the third example, here either you can flip these 3 zeros to 1, so that will take 3 flips, or you can flip these 2 zeros and make the complete string of 0, that will take 2 flips. So we did that, we just flipped the middle 2 ones to zeros. Got it? So here at first sight you might be thinking that yeah, this problem is about flipping the ones to zeros and zeros to ones. That means you have to make a choice, either to flip this 1 and 0, like either to flip this or to flip this, or how many times we need to flip. So you might be thinking something like DP, where we have choices. Okay, and further if we reach let's say we code one recursive function, and we reach if I equals to, and we reach, then we check for monotone increasing. So that way we can code a DP function for this. But before you do that, let me just show you the constraint, that is 10⁵. And if we try to write a DP solution, then it will short will give you TLE, that is time limit exceeded, and we don't want that. So instead of thinking about the DP like recursive plus memorization for each and every character of the string, you can think something different. Okay, think like that. See what we need zeros on left, right, and only ones on right, correct? This is the definition. We only need zeros on left and ones on right. We don't need something like that. We don't need zeros after 1 on right. We don't need something like 1 and 0. It must be either 0 1 or all 0 or all 1. Got it? So one way to do that is either so based on this you can think like, if we count number of ones on left, see you have seen this, and we need ones on the left and zeros on the right, correct, based on this condition. So instead of what we do count zeros on right. So number of zeros that are present in right, because these need to be flipped, and count of ones on left, because this ones need to be flipped, right? So if we do this thing, and we make and then we add both this for every index I to n, we add this 2 and we check for answer. Got it? Then will we get a solution? Okay, let us take a dry run for this example. So here let me write is ones on left This is the count of number of ones on left and zeros on right. For each index 0, 1, 2, 3, 4, 5, I will do this. So for the count ones on left, we will start from the left. So number of 1 before this 0 is 0. Number of 1 before this is 0. Number of 1 before this index is 1. Number of 1 before this index is 1. Number of 1 before this index is 2. And number of 1 before this index is 3. Got it? And start for the 0. Number of 0 after this index is 0. Number of 0 after this index is 1. Here 1. Here also 1. Here it's 2. 2 zeros after this index. And here also 2. So this is what we counted. Now what we are doing? We are just doing the sum. We will just add it. Okay. Add all these numbers. So here our answer will be 3, 3, 3, 2, 2 and 2. So for a second, what does this 2 suggest? For this index, 2 suggests that there are 2 zeros on the right. So if we can flip both the zeros, we will get our answer, right? Okay. So here at this index, what does 2 suggest? There are 2 zeros, the same thing. So if we flip them, we will get our answer. For this index also, what does this 1 and 1 suggest? There is one index on the left that we need to flip and one index on the right that we need to flip. And if we flip that, we will get our answer. Similarly, the index suggests this, that how many ones we need to flip from the left for this index and how many 2 zeros we need to flip from the right of this index. And this is the simple count and our answer is 2. Okay, so this is how we would approach this question, by taking the count of number of zeros on the right for the ith index and number of zeros of ones from the left index, and adding and summing them up, and the minimum of the sum would be our answer. So I hope you guys understood the intuition as well as approach of how we will solve this question. Now let's move on to the coding part and we will code the solution. First of all, let me take n as the size of the string, that is the total length. Now let me make 2 vectors to store the frequency of or the count of 0 and count of 1. For n, the thing is we need to count, we need to update count of 1 from the left. So let me start a loop from 0 up till n, and if s of I equal to 1, I need to do something. Okay, here I will take one count variable and initialize it 0. I will do count plus plus, and before that I will update c1 of I equals to count. Okay, now similar thing I have to do for I equals from the backend side to count number of zeros. I should be greater equal to 0 and I minus c0 of I equal to count, and if s of I equals to 0, then count plus plus. You might be wondering that why I am first updating the count and then why I am first updating this c0, that is vector, and then updating the count. Because see, for this 0, for this 1, we haven't taken it on the on this array. Once this is c1 array, because we need to find the number of ones on the left. So we first update our answer in this vector and then update the count for the further part of the array. Got it? And let us initialize one answer variable with n. See, because n is the maximum number of flip you can do. Now we will run a loop from 0 to n, and we will simply update the answer to the minimum of answer, and c0 of I plus c1 of I. Okay, that's it, and we would return our answer. So let us try to test our code. Okay, so let us try to submit this. So yes, our code got accepted. So as you can see here, this was easy question. If you have correct of how we would solve this, this is similar to what I guess it's a prefix sum thing, where prefix sum represent the number of zeros on the right hand side, and prefix sum from left represent the number of ones from the left hand side. And further, talking about the time and space complexity, the time complexity is big of n because we are just running a loop from 0 to n all the times, and the space complexity is also big of n because we are only storing n elements in the vector. So I hope you guys understood the question as well as solution, and that's all for this video. If you like the solution, then do hit the like button and subscribe to our channel for more such amazing content. Thank you.